In this video, we're going to be solving the tutorial questions on page 28 and page 29 of the course notes. There's 5 questions in total, so you may want to skip to the particular part of the video that includes the question that you're looking for. So beginning with question 1, we're asked to find, first of all, total resistance of this series circuit and the circuit current. Using the rule for resistance in a series circuit, in part A, we can say the total resistance is going to be equal to the sum of the two resistances in the circuit. Now, in some questions, we're not going to have our components labelled. I'm just going to choose to refer to this resistor as resistor 1 and this one as resistor 2. There's really no reason not to order them the other way around, and I just generally work from left to right. So you're very welcome to change them or call them A and B or whatever. So total resistance equal to resistance 1 plus resistance 2. These are given in the question, 330 plus 470, and this gives an answer of 800 ohms. Part B of the question asks us to find the circuit current. So we know in a series circuit that when we're using Ohm's law, and Ohm's law, if we remember, is V is equal to IR, that the supply voltage is going to be equal to the circuit current multiplied by the total resistance. And we have just worked out the total resistance, it's 800 ohms from part A. And we can see on the battery on the diagram, our supply voltage is given as 12 volts. So we can find the circuit current. So rewriting our formula, I is equal to V over R. We can then put in our values. We have 12 divided by 800. When you put this into your calculator, you're going to get a number that's less than 1, and you'll see the answer appears to be 15. But let's just explain what's happening here. The value you should see in your calculator is 0.015, and that's correct. And this isn't amps, because when we're working in ohms and volts, the answer's in amps. What the answer has done here is it has changed our units to milliamps, and like there being 1,000 millimeters in a meter, there's 1,000 milliamps in an amp. So we can multiply by 1,000 here to convert this and write 15 milliamps. For a value like this, so you'd be perfectly entitled in an assessment style question to leave it as 0.015 amps unless asked otherwise. And that's question 1 from the exercise sheet. Let's look now at question 2. So question 2, we have another series circuit. This time we have 3 resistors, but it shouldn't tax us too much, and we can have a look at how we're going to find out the information here now. Parts A and B are quite similar to question 1. In part A, we want to find the total resistance. We know this is given by the sum of 3 resistors' resistances, and we'll label these 1, 2, and 3 just to keep track of them. So RT is equal to R1 plus R2 plus R3. So that's equal to 10 plus 33 plus 22. And you'll notice in the question these are labelled with R's rather than the omega symbol for ohms. We can use these two interchangeably, but I will exclusively use ohms when writing my answers. So the omega symbol for ohms, I should say. So adding these together, we get 65 ohms. That's part A. Part B, we're asked to find the circuit current. So as was the case in question 1, the total supply voltage is equal to the circuit current times the total resistance. The circuit current, therefore, is equal to the supply voltage divided by the total resistance. The supply voltage is given in the question is 6, so we can put that in there. And in the previous part, we had worked out that the total resistance was 65. Putting this into our calculator gives an answer of 0.092 amps, which can be rewritten as 92 milliamps. So that's part B. Part C asks us to find the voltage drop across each resistor. And there's more than one way to answer this question. So we'll take one method in particular, similar to the example we saw earlier on. But if you do it a different way but get the correct answer, that's absolutely okay. There will sometimes be multiple ways to solve questions when we're looking at circuits. So let's start off and have a look. We can find the voltage drop across any resistor using Ohm's law. So let's consider resistor 1 first of all. The voltage dropped across resistor 1 is going to be equal to the circuit current, because as we remember, the current is the same at every point in a series circuit. So the current running through resistor 1, resistor 2, and resistor 3, and anything else we chose to add to this circuit would be the same. Of course, it might change once we change resistance, but for the current setup that we've calculated, it's going to be the same. And then that's multiplied by the resistance of resistor 1. And we know the circuit current, we've just worked it out in the previous part of the question, and we know the resistance across resistor 1. Now we have to be careful here, because one thing we don't want to do is put in 92 for a current. The value we put in here should be the value in amps, so it's 0.092. If we needed to convert from milliamps to amps, if we didn't have it this way, we could just divide by 1,000 to get around certain amps. And the resistance of resistor 1 is 10 ohms. So 0.92 times 10, like 0.092 times 10 is 0.92 volts. So we've calculated the voltage drop, the potential difference across resistor 1. Now we have to do the same approach for resistor 2 here, but again it's quite similar. The voltage across resistor 2 is going to be the circuit current times the resistance of that resistor. It's going to be 0.092 times 33. And we put that into our calculator, we're going to get 3.036 volts as our answer. And lastly, we want to calculate the voltage across resistor 3. Now we've actually got two options for solving this. We could do the same thing again, and I think we will, because we're going to use Kirchhoff's second law in part D, so we won't ruin the surprise of using that. To work it out in the same way, V3 is equal to circuit current times R3 is equal to 0.092 amps times 22 ohms. And that gives us a voltage drop across resistor 3 of 2.024 volts. Now, part D asks us to use Kirchhoff's second law to verify your answers to part C. Now, just remember, whenever we say Kirchhoff's second law, it just means that all of the voltages dropped across each component should add up to give us the total voltage supplied to the circuit. So what we want to check is that Vs, which is equal to 6 volts, is equal to V1 plus V2 plus V3. We want to see these two numbers are equal. So V1 is 0.92, V2 is 3.036, and V3 is 2.024. And it's probably not immediately obvious if these are equal or not. We have to add them up. But you can probably tell already they're going to be in the right region, because one's about 3, one's about 2, and one's about 1. So we'll put them into our calculator and see if they are indeed equal. And in my calculator, it comes out at 5.98. Now, this isn't an error. This is just due to rounding. But of course, if we round this to 1 decimal place, this is in fact equal to 6 volts. So don't worry too much if we're off by 200ths of a volt. That's simply because there's had to be some rounding. If we'd used exact calculators all the way through in our question, we'd have got exactly 6 volts as well. So yes, they are equal. So we have, and if you ever said this, we can say, since Vs equals V1 plus V2 plus V3, Kirchhoff's second law verifies You wouldn't always even need to write something like that, but a quick sentence at the end of a question like that, just to say, actually, yes, this is what we've shown here, is a good way to show that you've finished and you've correctly concluded the answer. So that is the answer to question 2. So let's move on and look at question 3 now from the exercise sheet. The question 3 may appear to be a slightly more daunting question, but really all it is just more resistors, and the math involved doesn't really get much more complicated. In part A, we're asked to find the total resistance. Well, we're quite well versed at this now. The total resistance is just going to be all of the resistors added up. I'm not even going to bother numbering our resistors in this case, because in this question, we're never asked to deal with any individual components. We're only interested in the total resistance for the circuit in part A and the current in the circuit in part B. So I'm just going to start from the left of our battery and add up all the resistances. So 2 plus 15 plus 22 plus 62 plus 33 plus 75. And if you put all that into your calculator, you'll find it is indeed equal to the answer indicated in the question of 211 ohms. And in part B, I suppose you know what we're going to do now. We've got Ohm's law. It tells us what to do when we know the total resistance and voltage supplied to a circuit. We can find the current by dividing that supply voltage by our total resistance that we've just worked out to find that we have 24 divided by 211, which is going to give us in our calculator something like 0.1137 amps, which is the same as 113.7 milliamps. We've multiplied by 1,000 to convert amps into milliamps, and there we have our answer, as is the case in the question. So sometimes in electronics, a way of making a problem look a bit more tough is just to add in some more resistors and to bulk up the question. But you can see it's just a bit of extra addition in part A, and we can solve this question quite happily. So let's move on and look at question 4 now. A circuit, oh, sorry, I put it on the screen first. A circuit has 3 resistors in series. Their values are 15 ohms, 24 ohms, and 60 ohms. Calculate the total resistance of the circuit. Now, this is a straightforward question, but what's different about this question at the end is we've decided just not to give you a diagram. But if we were to draw this circuit, it would look something like this. Well, this part of it would be our wire coming in. We've got a resistor here, and the resistor here. And we're told the values are 15 ohms, 24 ohms, and 60 ohms. And we're not told anything else about the circuit, but we can presume there's no other components. So we're going to have something that's a bit like this. We'll have some kind of voltage supply. This will complete our circuit. And there's no requirement to draw a diagram here, but I've drawn it to illustrate what the question is saying. We find our total voltage in exactly the same way we've done before, and we have 15 plus 24 plus 60, giving us a total voltage of 99 ohms. Part of solving questions is about interpreting them, but hopefully we can see quite clearly here how this has come about. Similarly, question 5 is another question that's a written question with no diagram, and it's always the case that you are very welcome to draw the circuit diagram, even if the question doesn't ask for it. So let's see what we have here. 2 resistors are connected in series. Their values are 25 ohms and 75 ohms. If the voltage drop across the 25 ohm resistor is 4 volts, determine the circuit current and the supply voltage. So but I did a little bit of thinking here, and I think a diagram will help us. Although you could solve this question without one. So let's draw in these 2 resistors. We've got a resistor here connected to another resistor here, and it's a 25 ohm resistor and a 75 ohm resistor, and that's our circuit. So we'll draw a battery in this circuit and connect it up. So what information do we have? Well, we do have something. We're told, if you wanted to, you could draw a wee voltmeter in here to show this. I'll draw it in just for the sake of it. The voltage dropped across this resistor is 4 volts. And we've asked to determine the current, circuit current and the supply voltage. Well, what we have been using is Ohm's law mainly to find the information about the whole circuit. But previously, in earlier questions, we did use Ohm's law on individual components, and that is true here. We'll name these resistors resistor 1 and resistor 2, so I can explain what I'm referring to. But for resistor 1, we now know that its resistance is 25 ohms, and its voltage is 4 volts dropped across it. We also know that in a series circuit, the current is the same at all points. So the current flowing through resistor 1 is the circuit current that we're looking for. So we can use a rearranged version of Ohm's law here again. And if you're looking at only at question 5, I explained what I was doing, getting this rearrangement. That's the one to the circuit. In an earlier question. So V1 divided by R1, the voltage of dropped across this resistor divided by its resistance. So putting the numbers we've got, we have 4 divided by 25, and that's what gives us our answer of 0.16 amps. So we now have the circuit current. But of course, we're also asked to find the supply voltage. We have to think about this a little bit more. The supply voltage we know is going to be given by Vs is equal to the circuit current times the total resistance. So we have just found the circuit current, and this means we need to find the total resistance. Well, we can do that because we know what the two resistors are. RT is going to be equal to R1 plus R2. 25 plus 75 is equal to 100 ohms. So we now have all the information we need. The supply voltage is therefore equal to the circuit current that we worked out in the first part, 0.16, multiplied by the total resistance, which we've just found, which is 100, and 0.16 times 100 gives us 16 volts. So we have worked out the supply voltage for the circuit. Now this concludes questions 1 to 5. Hopefully you found the video a helpful explanation of how the answers are obtained. If there are any questions, obviously email me or speak to me in class. I'm happy to explain further on any of these exercises.